I have the pleasure of introducing a guest who is going just to probably shake up your assumption about production. So Christophe is a founder of Chaos Management. He's on-demand CTO. He was head of production and quality at VP at SNCF Connect. And he's part of a circle of few people, certainly crazy people, who think that sometimes it's good to trigger outage to make sure that the resiliency of the system is good. So you will explain. This is it will be the first part of this presentation. The second part is a bit different. We will Christophe will talk about the context of building and running an information system and how to make it at some point very comfortable. Today it will be probably very or too short to talk about only about code, pipelines, technical asset, logs, to describe an information system. What is missing is certainly human factor, probably, and making the link between both of them. I think we can talk about engineering platform. So you will talk probably about mental health, human being, developer experience, and so on and so on. So as usual, don't forget to use and to scan the QR code to ask your question. You can do it live also because human part is very, very key. And now, Christophe, floor is yours.
Thank you. You say crazy, but you see, crazy is part of my name. So just to start, just a little bit myself. You said quite everything about it. Just thing to remember, I start in test and QA, then operation, then operational excellence, then CTO, and now all by myself. And if you want the full story, there is a very good podcast named Prodway, with an interview with Emery, and you will have 1 hour and a half about that. A little bit of chaos management. I will speak today about chaos and how to inject chaos or use chaos to develop serenity, because my real goal is not to create chaos, is to develop serenity to be able to manage chaos. So, I'm starting with the first question. In dollar, what is your estimation of the impact of downtime on breakdowns for Forbes top 2,000 company worldwide per year? Do you know the revenue of Apple last year? It's the equivalent, 400 billion damage for the top 2,000 company in the world, impact of downtime. You have the link. The presentation will be available if you want. You have all the sources inside. So it's a huge number. And to give you a little bit some example, Meta in 2024, 2 hours of disturbance, $100 million. Amazon, 1 hour downtime in 2021, 34 million. Alibaba, this one, I don't like it a lot. It's a simulation. It's during the 1 day, the full day revenue, the big day in November for Alibaba. If there was a downtime during the huge peak of this day, 20 minutes would have cost 26.5 billion. That's huge. And you? Do you know how many it costs in euro or dollar? 5 minutes, 100 minutes, 1 hour, 1 day. It's quite important. In fact, in quite all the company I did work in the past and still now, that's one of the first things I do. If you speak about 5 minutes downtime, sometimes some people will say, oh, it's 5 minutes, we don't care. Some other people, usually in the business part, will say, it's a crazy, it's the end of the company. So it's difficult to agree about a problem with only 5 minutes. But if you say 700,000 euro for 5 minutes, everyone agree, okay, it's an issue. So it starts by this. And I want to zoom. Oh, yeah. There is a lot of slides you will see, but to help you, there is some picture of my dog. So why not zoom in some emblematic incidents? And to do that, I will use something called Johari window. I don't know if you know about it. Johari window, it's the first quadrant is about, it's known by me, known by everyone. It's a non-known issue. Basically, it was Equifax. Equifax, it's a company who make credit. They did know there was an issue because of a CVE in the Strut framework. Everybody knows because it was available. They did take time to fix it, and it cost them a huge problem of cybersecurity and a loss of a lot of data, 700 million of tax in the US, 500,000 in the UK, 2 million in terms of business gesture to keep their customer. So it cost them a lot. But finally, they should have done something. There is a blind quadrant. I didn't know about it, but there is some hackers in SolarWinds. You put in the update system of SolarWinds, the deployment system, a virus, a sunburst virus, who help to bring a lot of issue in all the company and to observe a cheval de Troie, a Trojan horse, in the company and to survey them. So they didn't know about it. Some people know, the hackers did know, and it cost them, again, a lot of thousands and hundreds of millions of dollars to fix it and to still work with some company. There is a hidden quadrant. This one is not that tricky. In fact, I know about it, but I don't tell to anyone. In 2013, Yahoo have a huge break issue, lost a thousand of million of data, didn't say anything. In 2016, it was known when they were bought by Verizon, and it was discovered. So they lost 350 million of value during the sale to Verizon because of the fact that they hide this kind of issue. And finally, in fact, that's the one I'm more interesting, is the unknown quadrant. I didn't know about it, and nobody knows about it. And the last example was CrowdStrike. It was a huge issue last year with Microsoft. A lot of companies lost their platform, lost their server due to CrowdStrike update. And it was something could that be avoided because with enough tests, they could have seen it. But the fact that they were depending on CrowdStrike, they lost a lot of server worldwide. And what's interesting, in fact, it's for CrowdStrike, it's an issue. For Microsoft, it was not that an issue after because it was a way for them to sell a little bit more Microsoft Defender. And to be up to date, last week, Google Cloud were a big issue again worldwide. It's an interesting one. Again, an update of a core component with an issue, not enough testing, no feature flag. And another team tried to deploy a policy to use this feature. And unfortunately, they deploy the parameter with no value inside. So as soon as this deployment was done in terms of parameter, there was a null pointer exception, and all the server again fall down worldwide. A lot of services fell down about that. So we are in a quadrant quite difficult because you cannot manage it. The main point about this is you can do whatever you want. There will be incidents. You cannot avoid them. The only thing you can do is to do something to be better at managing it. That's the only thing to remember for today. And how you do that? When I use Johari, I like to meet also a framework named Cunefin, Cinefin. I don't know how you want to spell it. Cinefin is about the difference between disorder and order. Disorder, it's really a mess. You don't manage anything. But in the order world, there is 4 quadrants again. Simple is when you switch a light. You press the buttons, the light is on. It's easy, cause, effect. Complicated, you need expert, you need process, you need a book. It's complicated to build a car, but if you have the expertise and the book, the plan, you can do it. Complex, well, the link, it's a lot more difficult. There is a lot of cause, there's a lot of effects. You can manage it, you have practice. And there is a chaotic world. Well, you have causes, you have effect, and in between, you have a lot of things. And even more, if you move a little bit about the causes, you have a totally different effect, what we call the butterfly effect. So why making the point between these two? It's the way to manage the unknown quadrant. The unknown is the same way you want to manage the chaotic part of the Cinefin framework. And what does this say? I will focus there. Is you need to have new strategies. You cannot use the best practice, the good practice. You need to have new strategies. You need to act. First thing to do when you have in front of chaotic situation is to act, to be able to come back here. If someone tell you is to come back to simple, they lie to you. You want to have some strategy, some way to be able to come back to a more complex world instead of chaotic. How can we develop serenity in this world of chaotic and in the middle of a crisis? By developing robustness. I don't know if you know this guy, Olivier Amand. It's been around 2 years. We speak a lot about him and about this book, Antidote to Cult of Performance, Robustness from Nature. And I like the way he defines robustness because it's a bit more than resilience. Resilience is the ability to come back after a crisis. Robustness is about to be stable in the short term and viable in the long term, despite fluctuation. There will be always fluctuation. And I think that the world we are currently living, polycrisis in terms of war, on pandemic, on whatever, on politics, on geopolitics, everything, we are in polycrisis. So we need to be able to develop our robustness and to be able to prepare for the unknown, to be able to absorb this crisis and come back after and learn about it. So he defined for robustness based on nature by several key points. Redundancy, I think some of you know a lot about this. Modularity, plasticity, stress acceptance, and workaround mode. Redundancy, it's like us, we have 2 kidneys. We can live with only 1 kidney. But we have 2, we have redundancy in ourselves to be able to manage. And we know in our in production, in our infrastructure, to do exactly the same thing with offline backup, distributed architecture. The objective is to develop resiliency in unpredictability. Modularity is the fact to make some compartment to isolate damage. If you think about corals in the sea, corals is in 2 ways. It's a big, huge organism, but it's also a lot of polyp, small organisms, who are able to live together. And if there is a bacteria, a virus trying to destroy a polyp, the full organism is able to eject the infected polyp and create new one, a little bit like Kubernetes is killing your container and build new one. So it's coming from nature, and they did that since 500,000 years. So it might be a good idea. Plasticity, also organisms are able to adapt to their environment. Trees in a very windy place, they expand their roots very largely to be able to resist to the wind. We do the same thing to have some process to switch to different supplier, switch to manual process to adapt rapidly. Stress acceptance, it's the possibility to train our system. Your brain, you need to train your brain, you need to train your muscle to be able in period of stress and to work. There is some practice, chaos engineering, to do exactly the same thing, so to develop training and learning. And the last one, again, something you know, workaround mode, the fact that you have several possibilities to do the same thing. There is some fish who are able to live outside of water for 2 hours because they can breathe by their skin. It's the same. We have a lot of things in our system built by workaround, manual bypass, feature flipping to do the same thing to protect our system. So how we can use this robustness defined by nature. And again, I think you know everything about this point because in 25 years in technology, I already seen all of this. But this first time there is a link between what we do in nature, the robustness, and what we can do in technologies. What I want to speak today about for this way to build this robustness, to develop Serenity, is using platform engineering to industrialize and build robustness by design, observability to detect early your incident, and finally chaos engineering, training to deal with the unknown. Why do we need platform engineering? I think some of you start there. I heard some people today, and we are quite there. Everything is a lot more complex. We did have monolith very alone, and CrowdStrike show us that we are dependable on a lot of other software, of services external to our own information system. So the complexity of our system is growing every day with new capabilities. I don't like at all this graph because it's the antithesis of agility. But that's the reality we live in our company. There is a lot of framework and so on, and safe, and scaling, and Cinefin, and design thinking. We had more and more process. It's becoming crazy for our team. And at the beginning of deployment of agility, I remember speaking about the fact to move our people from specialist to T-shape people to help in terms of bus factor. Bus factor is if someone of your team is under a bus, you can still have your team functioning. I prefer to say it's when someone of your team go in vacation, still working. So we build some T-shape specialties. You have one specialty and you have some other specialties, not as an expert, but to be able to deploy in production, do some testing, write user story, and so on. But year after year, we move from T-shape to P-shape to peigne, genre j'ai oublié comment on dit peigne, peigne shape. Well, in fact, we had the name for this since a long of time. Le mouton à 5 pattes. Sheep with 5 feet. So that's the reason platform engineering is coming. Platform engineering is the fact that we want to still have autonomous team to be able to build, develop, operate their services or their application. But we don't want them to become a specialist of everything, specialist of Terraform, specialist of service mesh, and so on. So we want to provide them a platform to be able to build and run any services, any application they need to do. Some people think platform engineering is building this internal developer platform. No. This is the result, this is a product, but as a website, as an application, is a living thing. Your platform will live also. It's not you build a platform and your team can live alone. I live I think 5 years ago, we did have this same idea to build something, CI/CD to our team, and dismantle the team after that. We say, okay, now the team can use it, and it will be okay if they want to manage, change a little bit some Terraform script or Ansible script, they can do it by themselves. 6 months later, CI/CD was not more working at all because nobody was in charge and everybody was just complaining about it. So it's some back and forth on this kind of thing, but it's not about building this platform. It's about changing our way to work with the team. And why we do that is because the platform engineering will bring you by design robustness. If I come back to redundancy, modularity, plasticity, stress acceptance, and workaround mode, by redundancy, by default, you want to build inside your platform a lot of functionality to automatic deploy, automatic using, for instance, Kubernetes to destroy an NLC virtualization machine, pod, I'm losing my word, pod, and build a new one. You want to integrate your backup inside. You want to orchestrate your services to, by default, build isolation. You want to do some auto-scaling, but not only this. Use feature flag. If GCP last week a feature flag of the new functionality to stop the deployment of the problem, they just have to feature flag, and that's all. It's stop. Everything you know, I don't want to go back. You can take picture. You can have the slide right after. But by default, you want to build all the capabilities to robustness inside the way you want your team to build it. You don't want your team to think about every single thing of this, but you want them to provide them the platform to do it, again, by design. How do we get there? First, some people might think platform engineering, well, we come back to the production team that we have had before. They were able to deploy, they were able to provide our server and so on. We go back to that. No. It's providing the management of some commons for the teams, but the teams still are autonomous to use this. And you have a product approach to the platform. If your platform engineering team tell you, well, we had service mesh in our platform because it's the fun thing and everyone speak about it right now, but there is no team who need that, they fail. The only thing they have to do is to have a product approach to the platform, to speak to their customer, and the customer are your development team. They don't build the platform for anyone, they build the platform for your development team. And they focus on the common problem. Again, if one team need a service mesh, maybe they can try and use service mesh. And if later there is more and more teams who need a service mesh, it will become a commons for everyone. So you don't want the first team to manage the service mesh for everyone. So it will come back to the platform team. As I say, it's not a go back to what we have 20 years ago, a product team isolated. It's really an opportunity to manage commands, to help the team to focus on delivering values with the best tools, the best platform. And finally, if there is a world when you don't want to build everything, to make everything, it's in platforms. There is a lot of tools already existing. Choosing the right tool, integrate the right tool, facilitate the use of this tool by your team is probably the best thing to do instead of trying to make everything. We will have a focus on chaos engineering later. When I started chaos engineering 8 years ago, there was very few tools, so we make it. Today, I will show you there is a lot of tools to do it, so don't do it. Use the tool existing, choose between several, but build your platform by using and choosing the tool who will comply with your company, your rules, and your teams. And if you remember all the list inside the robustness, there is one point which is quite interesting for me, is a way to reduce and accept stress. Because we did speak earlier up there about mental health, and managing mental health, it's helping human, helping people, and detect when they are in a situation of an issue, but it's also trying to do what we can to avoid stressing situation or to train them to be able to accept this stressing situation and to be accustomed to it, but not in a way that they are always at 200%, but in a way that they are at 80% on everyday basis, and sometimes they can go to 100% to manage this stress. The first point is observability. I think it's not the first time you hear about observability, but I still feel it's not enough today in our company, the way we manage observability. And to come back to the first incident, I start with this talk. We cannot prevent breakdown. You cannot prevent incidents. There always will be. Even GCP, even Alibaba, even Amazon, who are huge company, who are a lot of process of resiliency and so on, they had incident. It's normal life. What you can do is to be able to detect and respond very fast. And as I showed you just earlier in terms of framework, in terms of tools, complexity is exploding. And monitoring tool was designed for a predictable world, for the known, not for the unknown. Because with monitoring, you focus on a question you have. You already have a question you had in the past and say, okay, I know that sometimes the memory of this kind of server is going too up, so I will have a focus, a monitoring of this memory for this kind of server. But maybe it's another one who will have the issue and you don't have any alert, any monitoring. There is also, when you have in crisis, when you have an incident, you have always, I will say sometime, but in fact always new question, something you never asked before. And I think I remember, I tell this story earlier today. One of the most problematic moments I had in one day was we have a huge crisis. Application, the website was down. And the team tell me we have a hotfix. So I call the business team, say, yeah, we have a hotfix. And later they tell me, no, we have a hotfix to have more log to understand the problem. Oops. And that's a pain to have to deploy something to know a little bit more about application, to be able to detect an incident and understand it and fix it. That's painful. We need to change something. And if we want to help our team in production to be less stressed, give them the tool to be able to see and analyze easily and not have to, again, add a new log, a new event, a new thing to do that. Monitoring is really about threshold, alerts, monitoring the health of a system. Observability, it's whatever question I have about my system, I should be able to ask it without any deployment. When you have a monolith with log, maybe it was not useful, but today it's not what we have. We have a lot of different things. Now we have the serverless, and you don't even have the server to look at. You have something that happened for 2 seconds, do a function, and then disappear. How you can analyze this? So there is new tools. There is a lot of tools in terms of observability, but there is also a way to use these tools. You may have some. I will show you right after some tool. If there is one CTO in the world you need to follow, it's Charity Majors. She's very interesting in every subject in engineering, but she's a specialist about observability. So this book is quite interesting. So when we do observability, we do instrumentation. We are managing events, not metering. We do not aggregate. I know in terms of storage, it might be an issue. So you can decide the time you want. It's maybe just today, it's maybe a week, but you don't aggregate because every aggregation is a loss of information. Few dashboards. Why it's important? You have some, I think maybe of you have some Dynatrace, Datadog, New Relic tool, who are good tool to do observability. But the way we tend to use them is to create our dashboard. So in fact, we transform a tool which will help us ask some question to monitoring. We create some dashboard and we focus on this dashboard, and maybe we don't see the issue who is there, who is not on the dashboard. So maybe it's useful to have few dashboards for your management, for your CEO, because they want to see something. But the best thing to do is to use the capabilities of these tools. We are able to, using AI, to generate alert in terms of differencing between the current behavior and the baseline behavior, and use this to analyze, ask questions, and fix it. If you build dashboard, too many dashboards, you will. Most of the incidents I have in my previous life, since I use this kind of tool, are because they happen in this place, not in the dashboard. And do some production testing. And the question is, how do you test? It's coming, it's coming. First, I won't lose some time. Just I give you some tool because it helps you. Again, Dynatrace, Datadog, New Relic are quite good. Splunk also. Charity is the head of Honeycomb. It's quite different approach, but it's quite interesting. I don't sell this tool. It's not my job. But just to give you some list to be able to help you. So the other part, how you test it. Chaos engineering, and I know that's the main point. Some of you are there, so I will take a little bit more time on this. I love to start by Bert Lance in 1977. If it's not broken, don't fix it. The philosophy of chaos engineering is, if it's not broken yet, try harder. So, why do we need this? Because, in fact, we don't know how close we are to chaos. We don't know if it will break. We think we know, but we don't know. How can we have confidence in a system more and more complex when you depend on so many API out of your information system? With so many interacting components. In fact, you cannot even, if you have some tool like Datadog or JSON, they try to build you a screen of the link of all your components, and nobody can read it. It's just a huge mess. And you think you can manage this. So no, you can't. And you will never be able to prevent any issue. So what do you want? You want to be wake up at 3 in the morning on a Saturday night because of an issue? Or try to inject some chaos during a Friday afternoon, a Thursday morning, in a manageable way, learn about your system, update your system to avoid to be wake up in the weekend. I prefer this solution. And chaos engineering is this part. And it's really about experimenting your system to build confidence. One point I insist, if you know that you will break something when you inject chaos, don't do it. If you already know, that's not the point. If I shut down a database to try if my Redis cache will work and my website will show every content from my CMS link to the database, if I know it's not working, don't do it. But if I think, if I shut down my database, the Redis cache of my website will work and my website, nobody will see that I lost my database, try. And maybe you will learn that it's working, but it's working for 5 minutes because you have a TTL of 5 minutes. And you say, oh, okay, maybe I should update my TTL. So you want, the purpose of chaos engineering is to learn about your system and learn about things you think to know, you know. How you do that? First, you make an hypothesis. For instance, I think that if I shut down my Drupal database, my website won't have any issue thanks to my Redis cache. That's my hypothesis. Define a perimeter. Do you want to do that on all my website? Maybe one website? Do I have the enough observability tools to manage and see what's happened? I am able to ask any question about my system if there is an issue. Inject chaos, could be only shut down your database. Analyze, and the most important point, industrialize and do it again. Not one time. If you do it one time and you learn something, our systems are live being. They change every day, every week, every month. So something that's working today might not work in a month, in a year. So try to industrialize and do that every X days. Some companies do a failure Friday, some game day on every Friday, not always the same, for instance. And one important thing, Nora Jones is one, she was working at this time at Netflix, said, set up a chaos experiment isn't the best way to meet your new colleagues, but it's the fastest. In real life, what is injecting chaos? There is two kinds of systems. There is your platform infrastructure application. It will be automated experiments, but your system is not only machine, it's not only server and application, it's people, it's process. So you need also to stress your system to train them. And so I will cover these two parts, automated experiments and game days. It all starts with this, the chaos monkey. The idea was coming from Netflix. They were on Amazon AWS. They want to test their autoscale system. So they built a chaos monkey who was shutting down any server at any time to test if the scaling system was working and was able to detect the server is down and build a new one. The interesting point in this is if you are old enough, like me, you remember in your specification, sometimes in technical specification, there were a small paragraph called technical specification about resilience, about latencies, and so on. Now, if you are lucky, you have this paragraph. If you are even more lucky, there is something in the paragraph. If you are even more lucky, someone read one day this paragraph, and in a good way, someone will have the time to test it before the launch to production. In real life, a lot of companies didn't have anything of that. And the change with this is it's not trying to build a resilient system to be able to prevent the loss of a server or loss of a database in production. It says to your team, don't cross fingers for this not to happen, because it will happen. We will purposely destroy your server and your database, so make your application resilient. Of course, start by production at first. When we did that at SNCF Connect, we also didn't start by production. But we did it in production at the end, with the team who wanted to do it, and who feel that they were resilient enough to do it. And we did it with some very not critical system, but also with one huge middleware system for SNCF, so it's possible. And in fact, because we are a bit crazy, as I said, we even did a Chaos Kong. A Chaos Kong, it's a little bit more lost the data center. So we simulate during the night. We didn't do that during the day. We don't that crazy. The loss of one data center in a PCI infrastructure with a load balancing between two data centers. In fact, it's not load balance. It was a 50%, 50%. So we simulate the loss of data center. First time we did it, the production team didn't detect it. They didn't receive any alert. And 1 hour later, we say, did you see that we did that? The second time, because they were a bit frustrated that they didn't see, they were able to see it, but 2 hours later, they were not able to detect where was the problem, what we did to simulate the crash of the data center. So time after, they were better. They update their monitoring. They try to do some observability, and time after time, and we did that a month, and the next month, the next month, and right now we are on the cloud, so we don't need that anymore. But at this time, we had two data centers, and it was very useful to be sure that our scaling and load balancing system, in case of losing a data center, and Chaos Kong allows us that. But again, we didn't do that only once. I think, I don't know if there is OVH people here, but when they lost two data centers in Strasbourg, I'm quite sure they did disaster recovery. But maybe they didn't did it every 6 months and every change. Maybe if they did regularly, they could have prevented this. But because chaos engineering, if you don't do it just once, forget it. It's the regularity. I used to say in operational excellence, excellence is an habit. It's Aristotle, it's not me. Excellence in an habit is something you do regularly. If you just do it one time, again, forget it. So, as I said before, there is a lot of tools. When we started, we did some kill-9 to kill some server. Now there is a lot of tool inside the cloud provider. There is some very good tool, Gremlin and SteadyByte, SaaS platform to help you. The one from cloud provider are just to inject chaos. The one from the SaaS platform is the full process, make the hypothesis, observe, and inject chaos, analysis, etc. But everyone does not want to buy tools. So there is a lot of open source tools too. And these three ones, Chaos Toolkit, Chaos Mesh, and Litmus, are coming from CNCF, the Cloud Native Computing Foundation. So we recommend them. So there is a lot of tools. So you have no excuse to try it. But as I say, it's not only your system. Your team, yourself are part of the system. So if you only treat one point, you miss the story. Because when you are in crisis, at some point, it will be someone from your team you will fix it. You will have to do something. So what we did is what we call a day of chaos. So we built that exactly like a game. You have to experience wave of failure from deep within your operation. Your mission is to fend off these waves and to detect, diagnose, and resolve as quickly as possible. The future of our production depends on you. It was 240 minutes, a full day. It was 7 teams. By teams, 3 to 7 players. Each team was working on their application, not in production, in their development part. And each team, as we inject chaos, have 100 points when they detect, 150 points when they diagnose, 200 for resolution, and the first one to detect, because it's the same chaos we inject in each application, have a bonus of 100 points. And if they ask a hint, they lose 50 points. There were 8 rounds, 8 failures we inject in the system, and the 3 first have some rewards. So the way we do that, we inject an incident. For instance, and this one was the first one we did, you have your health system, you have something like an URL for your application on one server to check if your server or your application is up, and you have a load balancing for all of that. So we change this URL in each application without telling it, of course. So all the server was up, all the application was running, but for the load balancer, all applications were down. So your application, non-application were working. And so the problem was to detect that there was an issue that may happen during a deployment in the health URL. And the development team, because at this part of the story, they didn't care about production, to be fair. So they didn't, most of the team, I think 80% didn't detect that. We have to give them a hint, and then diagnosis and resolution came. Why I make a focus on this one? 1 week later, and we have luck, and it's good to have luck sometimes. 1 week later, in production, there was a failure. Someone make a mistake on this URL, and we had 10 minutes to fix it. Thanks to that. The same mistake, why we choose it, is because 2 years before, it takes 2 hours to fix it. So we move from 2 hours to fix it to 10 minutes. Again, we were lucky for this to happen right after. But it's a way to show that it really helps to train your team in case of crisis. At the end of incident management, we reset the environment, build a bonus question, and it's very important, it's about training. So if some team didn't learn and didn't find it, we have an explanation video to show them how it was provoked, how you can fix it, and so on. And these videos are always available, and you can even put it in your support process for the team working the night. The result, 113 players. If you remember, we did plan for 17. We had 18 teams. It was a little bit more than expected. 87% detection for all the round, 73% diagnosis, a little less resolution, but it was the first. In terms of interest, 80% interest. They love the organization quality, not as much as we wanted, but again, we planned for 17. We had 18 teams. And 74% learning. And it was again in 2017. We were all in the office, if you remember. It was before COVID. And the 3 winning team was a team who had observability dashboard on their bench to follow the production and to follow their environment. I think in the next months, all the team did have the same thing because they want to win the next time. So it really helped in terms of deploying production and operation and practice to development team. They had technical tests. They share a lot, and even more. We had the lead tech of the team who say, "Oh, it's quite interesting because every time I go in vacation, they call me when they have an issue because in crisis, I'm the one fix it. So now, before going in vacation, I will do a game day, a Friday afternoon, simulating the most issue I have in the past 3-6 months to train them, and this time I will be okay during my vacation." In summary, I know, oh yeah, I'm good in time. Platform engineering is building robustness by design. As we in DevSecOps, you are trying to build security by design. Platform engineering is really trying to build robustness by design, by automating redundancy and modularity, instrumenting plasticity and degraded operation, and institutionalizing stress tests. It's really a resilience accelerator for mature organization. Observability is a way to have real-time information about your system. Chaos engineering to simulate failure to your and test your resilience. And again, regularly train. The concept of chaos engineering is coming from someone from Amazon. And the interesting thing is he was a firefighter before. And firefighter, what they do, most of their time is training. It's not stopping fire. It's training to be able to stop fire. And chaos engineering is exactly the same thing. It is to train again and again, trying to find the time to train your team to be able to manage crisis, to manage failure, manage incident, instead of to waiting one for happen. And again, what is not exercise will erode. So the sentence to remember. Thank you. I put some books about it. Team Topologies is the book about platform engineering, observability engineering, chaos engineering, and if you remember the book from Olivier Hamon about robustness in nature, again, it's 50 pages. It's very fast, but very interesting. And if you don't want to read the books, there is a lot of video about Olivier Hamon. I really encourage you to listen. That's all for me. Oh, no, sorry.
Thanks a lot, Christophe. You've been very, very efficient in a very short time, and we ran late, so thanks for that. I'm sure we can get a couple of questions, maybe. Yes, one question. Thanks for that.
So I have another talk about convince leadership to do chaos engineering.
And complementary, and the business.
And the business. I will do the summary of it because I really have a talk. You will find it online. The first one is to make this familiar. You know, freeze, fight, and fly, which is the way you manage with something you don't know. So don't come to your CEO, your CFO, I want to break everything. Share some posts, some article about, oh, you see, some company like we SNCF did it. That's why, that's why I write a lot of articles about that, to be able to share, to make this thing, oh, there is something called chaos engineering. That's the first part. If you come directly to say you want to do it, they will fly or freeze. Second part is, I don't know if you know the story of the elephant and on the 7 wise men. So there is 7 wise men, but 7 blind wise men who come and for the first time close to an elephant. And the first one is touching the head or the leg and say, oh, it's a trunk, it's a tree. Another one touching the, I don't know the name of in English of part of the, and each part they think it's a snake, it's a snail, it's a paper, and so on. So why I use this? It's to everyone you speak about this, the business team, your CFO again, try to find the one thing that may be interesting for them. If you go to your CTO, tell them, well, Netflix did it. I think we should do it. If you see your the manager of operation, you use the example. Do you want to wake up at 3 in the morning on a Saturday, or try to train your team before? If you go your CFO, speak about the 500 billion they can lost in 5 minutes. Again, find the right argument for each of them. And then there is something we call in France sociodynamic, allied card, trying to find in the people you want to convince, who are the people who can be ally, who can be definitely against, and use your ally to not let the against people speak, and try to use the ally to make the people who are not so against to follow you. So again, it's very short, but it's working. Again, I really did that. We first tried to push some information. I didn't know our CEO follow me on Twitter, so I pushed a lot of articles about chaos engineering on Twitter. Really. So the first time I did speak about this, they said, "Oh yeah, I read that at Netflix," and so, because it's if not, it makes them afraid. But again, leadership, influence in leadership, and you will see the example is chaos engineering.
Thank you. Did you already provoke a severe outage in production with Chaos Monkey in your experience? And if so, how did you react and how did you explain?
An unplanned outage in production.
Yeah.
Well, the loss of the data center was one. But no, it was planned. This one was planned. No, we again.
A major incident.
A mistake.
Mistake.
Fortunately, until now, not.
Merci. You just discussed about how to convince the management and all, but it's always about cost and organization. So how do you organize it? Do you have some dedicated people to do that, or because the main challenge every time, I would like to do that for sure, but the main challenge is that we don't have time, we don't have people, we don't have money. So
yeah, I know.
No, but I just want to understand how it can be organized, just to try to start the topics.
Yeah. Something I forget to tell, be opportunist. The first time we tried it, in fact, it was after a major outage. And I told them, if you want to avoid, your management, the comics always say, I don't want this to happen again. And you say, yeah, I have some strategy to do it. Let's do chaos management to avoid it again. Even if it's not really the way to do it, but it will open some money. That's the first thing. Be opportunist. And the second one is you need people. You cannot just do it between the line, as we said. You need some people, not a lot of people, because it's mainly people who facilitate, who organize game. Yes, it costs money if you make a game day with 18 teams for one day. It's like a hackathon. If you maybe use the same argument you use to organize a hackathon, to organize a game day. But always the first thing I do, and I really recommend to do that, is trying to know what costs 5 minutes of downtime of your application. That's the key, really. If you don't know that, if you can explain, if you lose 1 hour, you will lose 100,000 of your. It's difficult to manage to introduce chaos engineering.
I would have another quick question, please. Can we consider that the chaos training is a part of continuous improvement or no?
Yes, definitely. My main job is operational excellence. That's to say, build improvement, continuous improvement at the steps of the factory, the full team. The Scrum Master is responsible of continual improvement inside the team. I'm the huge scrum master of all the IT department, of the tech department, and chaos engineering is definitely a tool I try to install every time. And even as a CTO, I did it.
Okay, thank you.
Yeah. During the opening keynote in Vivatech, Johnson Wong talked a lot about the virtualization of the physical world within AI to reduce the time to build products, but to test products. Do you think there is an opportunity for virtual Chaos Monkey with AI to replicate your IaaS within your AI and to simulate outage in the AI to avoid this impact? What do you think about that?
Two parts. First part, I love it if we can do it, but the purpose of chaos engineering is to do it on your real production with real live user. And we try in the past to have a pre-production close to production. It's never happened. Maybe one day we will have an AI simulation close to it, but my experience is the only real life is when you have user, because you know, every one of us are very crazy people, and we can invent something that nobody think and to do with our application that even the best AI will not do. But I'm not in the future. We don't know. I love it will happen one day, but thank you.